So, 8.5. So it says, remember from the beginning, to determine if it's geometric or not, find the common ratio. So what's happening here is, this is being divided by 3. And this is being divided by 3. Okay? So if it's being divided by 3, so since it's being divided by 3, yes, it's geometric, and R is 1/3. It's being multiplied by 1/3. Okay? This one, 25, 30, 35, 40, this is plus 5, plus 5, plus 5. That is not geometric. It is arithmetic. Okay? So it's going up by the same number. So that doesn't count. All right. As we already talked about, explicit means a sequence which allows direct computation, calculating it for any term in the sequence. I want the 17th number. I want the 35th number. Okay? That's what it means. Recursive means a sequence where the starting term of the sequence is always given. You know where it starts. And then you figure out the next term and so forth. Okay. So the explicit formula for geometric is similar, okay, where A1 is the first term, like we had with arithmetic. R is the common ratio, so instead of the common difference, we have the common ratio. And N is my term. So we're going to be substituting in, we're just going to be substituting in a different formula than we did with arithmetic. But the concept is still the same. So if I want to find the first term, I'm going to plug in 1 right there. And then crush the numbers. So 1 minus 1 is 0, right? Anything to 0 power is 1. So 3 to the 0 is 1 times 2 gives me 2. Then I'm going to plug in a 2 for n. 2 minus 1 is 1. 3 to the first power is just 3 times 2 is 6. Then I'm going to plug in a 3 and a 4 and a 5 and so forth, over and over. And I get 2, 6, 18, 54, 162. Okay? But look what's happening. Times 3, times 3, times 3, times 3. Right? Didn't we say R was 3? Okay. So that makes sense. It is the rate of change, the common rate of change is times 3. So we can confirm that when we're done. Same idea. Find the first 5 terms. We're going to put in 1, 2, 3, 4, 5 right in for n. And crush the numbers. So we do that. 1 minus 1 is 0 again, which makes this just 1 times negative 1 is negative 1. 2 times 1 is 1. So 2 times negative 1. 3 minus 1 and so forth. Okay? And what's happening? Times 2, times 2, times 2, times 2. If I'm adding stuff that's not on your notes, you should be adding that also. There's going to be a little bit of writing for you to do. Okay? You can confirm this should match. That should be the same. If your numbers don't follow that pattern, you made a mistake somewhere. Again, the beauty of math, you can check your work by calculating and verify. So if R is 2, and we had negative 1, negative 3, and so forth, negative 6, then that would be we were multiplying by 3 instead of 2. Something went wrong. We can confirm. Okay, given the explicit formula, for a geometric sequence, find the common ratio and then the term named in the problem. So we want to find the 5th term. Well, this is the common ratio, just that number. All you have to do is say R is 4. All you do is write it like that. Okay? That number, that base, the base for the exponent, n minus 1, that is R. So it's already there. You just got to say R is 4. Then for the 5th term, all we're going to do is put a 5 right there. 5 minus 1 is 4. 4 to the 4th power times 2. That's it. So 4 to the 4th power is 256. Double that, you get 512. So very similar to arithmetic, totally different formula, but the concept is the same. To find the first 5 numbers or 17th number, you just plug those numbers in right here for n. If you want to know what r is, it's right here. Very similar concept. Okay. Now this time, given the first term, which is a1, right here, given that, and the common ratio, which is this, okay, find the formula. Just substitute in the numbers we know. 3 goes there, 2 goes there, that's it. Yeah, we leave it n minus 1 because I just want to know what the formula is given this information. That's all you're doing. Given this information, what would the formula look like? Now that I have it plugged in, if I said find the 50th term, you put 50 right there and crunch the numbers. That's how you find the formula. Okay, so A1 is -2, R equals 2. That's a couple pages over. Okay, might have to skip a couple and find this one in your packet. A1 is -2, R is 2. Okay, so we just plop the numbers in. A1 goes right here. R goes right here. There's my formula. Okay? Then, if it says find the first 5 terms, we're going to plop in right there 1, 2, 3, 4, 5. So let's do it for the next one. There's my A. There's my R. And this time we're going to put in 2 minus 1. Fill that out with the sound on yours. It is on yours. All right. We then crunch it. 2 minus 1 is 1. 2 to the first is 2. Times -2 is -4. It works out. Okay. So basically, this is what your formula looks like. You know, you need to know what your A1 is. That's going to be a number, whatever that number is. And then the formula is going to be like so. That's your recursive formula. So now we're going to apply that. So, given the first term and the common ratio, find the recursive formula. Well, we literally just write, put the an there, a sub n, plop that in right there, and then we leave this in that format, a sub n minus 1. And then we just leave it like that. That is the formula. If we were going to do anything with it, you know, then we have our first number and we could go from there. But that is the formula. We just plop basically the R into the equation. Now, if we wanted to find the next number, we know the first number is 2. Okay? We want to find the second number. All right? We put it into our equation and go from there. Okay? Our second number would be 8, and then we'd have 30, and so on. We go from there. All right? All right. So, given the first term and the common ratio, same thing. Okay? So it's the same format here. Write the an, this is the basic formula, plop this in there, leave that as it is. Okay? And if we were going to ask for the first 5, you'd start with that one. And then go from there and find the rest of them.